Hey, hi everyone. I hope you all are doing good. So, in my today's session, I'm going to explain about one more uh, behavioral design pattern called template method. So, let's start with it. So, what's a template method design pattern? The template method is a method in a base class, usually an abstract base class basically, and defines the skeleton of an operation in terms of a number of high level steps. Okay, these steps are themselves implemented by additional helper methods in the same class, that is the abstract base class, as the template method itself. The helper methods may be either abstract methods, in which case derived classes are required to provide a concrete implementations for them, or hook methods which have empty bodies in the base class. Derived classes can customize the operation by overriding the hook methods. The intent of the template method is to define the overall structure of the operation. Okay, the intent of the template method is to define the overall structure of the operation or a algorithm or a workflow, while allowing subclasses to refine or redefine certain steps or activities. Okay, so basically what template method design pattern is, it basically gives you an structure of an algorithm or a workflow. Okay, and what are the fixed number of steps in the proper order. Okay, so it basically specifies if this is my workflow, then activity 1 2 3 4 5 6 7, these are the steps, okay, needs to be executed in order to complete this algorithm or workflow. You can't do activity 3 first, you can't do activity 5 first, so you can't alter the order basically. So you have to adhere to that sequence basically, or the steps, high level steps you have specified. Okay, so this pattern is an example of inversion of control, because the high level code no longer determines what algorithms to run. A lower level algorithm is instead selected at runtime. Yes, because a high level algorithm, whatever you are specifying in terms of an abstract base class, is basically a structure. Okay, it specifies the order or structure of your algorithm, but ultimately the concrete classes which inherit from this abstract base class, they will define what algorithm needs to be run at the runtime. Okay, so at the first glance it may be confusing for you people, but let me explain you with a demo, okay, in few moments. So what solution template method design pattern provides? Okay, so the template method is implemented as a method in a base class, usually an abstract class. This method contains code for parts of the overall algorithm that are invariant. Okay, so do understand this concept. This template method contains code for the parts of the overall algorithm that are invariant. Okay, so take an example. Okay, take an example of building a report. Okay, so in order to build a report, suppose I need to perform 5 activities. Okay, so the first activity is being establishing a connection to a database. Second activity, okay, being constructing the header. Third activity, constructing the body. Fourth activity, constructing the footer. Okay, and then fifth activity being printing the report or generating a report basically. Okay, so these steps are not going to change for any kind of report. It may be a PDF, it may be xlx, whatever it may be, whatever format you want to print. Okay, but these orders are not going to change. So without making a database connection, you won't get your data. Okay, so first you establish the connection. Second, you run the database query to get the data. Third, you perform some business operation on that data in order to get the report data, in order to get the report information. Then you construct the report and then you convert it to a final format. Okay, these steps, okay, these are called the primitive step of your algorithm, which should happen in the specified order only. They should not change for any reason. Okay, but only thing, as per the client's requirement, okay, there are some variant steps basically. Now when it comes to generating the report, okay, a report can be generated in PDF format, it can be generated in a xlx format, or in any other format the user wants. So this kind of step is called variant step, because the step changes based on the type of report I want, whereas the invariant step are the ones which are not going to change. For example, making a connection to database, okay, getting the data, processing the data, constructing the body, okay, creating the information, and then generating the report. So these steps are invariant, which are not going to change for any reason. So these are called our invariant steps. Okay. So in the template method, portions of the algorithm that may vary are implemented by calling the additional helper methods. In the base class, these helper methods are given a default implementation or none at all, which are basically a pure abstract functions. Okay. Subclasses of the base class fill in the empty or variant parts of the template or algorithm or workflow with specific algorithms that vary from one subclass to another. Okay. It is important that subclasses do not override the template method itself. Okay. So just understand a process. One more example I will take. What is the process to build a house? You first lay the foundation, okay, and then you put a bedrock, okay, and then on that you start building walls, okay, and then you fit the windows and doors, and then you start the painting. Now just imagine, can you alter this sequence without laying the foundation? Can you start building the wall? No, that is not possible. That's what they are saying. It is important that the subclasses do not override the template method itself. Okay. Basically you can't alter the primitive steps associated with your algorithm or workflow. Okay. So the algorithm must go in that order. That's why it is important that your subclasses should never override the template method. Okay. So that's the solution basically the template method design pattern provides. It contains two steps basically. Okay. So the first solution, what is, the template method is implemented as a method in a base class. Okay. This method contains code for the parts of the overall algorithm that are invariant. Okay. Which are whose steps, whose sequence are not going to change for any reason. Okay. One such example is building house. Okay. You can't build the wall without laying the foundation. No, that's not possible. Okay. And then the template ensures that the steps of the algorithm are always followed. Okay. You should follow that sequence basically, or the order. Now the second part is, in the template method, portions of the algorithm that may vary, okay, which are implemented by calling an additional helper methods. Okay. So what are these varying steps are? Now take an example of building the report itself. Okay. Now for one of the report, okay, the first step is establishing a connection to the database. Okay. So now this connection can be made to a SQL server database. Okay. Or this connection can be made to a PostgreSQL database. Okay. Or it can be made, or you can make a connection to some other SQL database. Okay. Even if the underlying data store is changing, but establishing the connection is the first step. Okay. So that is invariant step, whereas connecting to any kind of database is a variant step, so that can be implemented by the subclasses basically. Okay. Just remember, this is the main solution. These are the two main solutions that solution, sorry, this template method design pattern provides basically. Okay. So let's go on to the usage. Okay. Some real life usages I would like to say here. Okay. So yeah, the Angular lifecycle hooks, where the template method with the lifecycle hooks has been used in order to give the subclass more control over the lifecycle of a component. Okay. You would have seen, okay, on init, okay, on loaded, okay, on destroy, this kind of lifecycle hook events, right, which basically allow you to add your custom logic in order to handle all these lifecycle events associated with your component. Okay. So that's what they are saying, how is constructed, what happens when something is changed, and if there are additional properties that needs to be destroyed once the component is not required. So this is basically an example of a template method implementation. The payment gateway has a few steps that are defined in the template method, like validating the payment, transferring the money, and updating the database. Again, these are invariant steps, whereas variant steps being, okay, what kind of payment gateway is happening? Is it through debit card or credit card? This is invariant step. Okay. What payment gateway you are picking? Okay. Again, that's an invariant step. Okay. So these are some real life scenarios basically. Okay. So let's move on to the demo now. So I have taken an example of building a car. Okay. A workflow to build a car. Okay. So provide a keen observation. I have an abstract base class. Okay. So this abstract base class basically specifies, okay, a template method called build car. Okay. So in my example, what is my template method? Build car. Okay. Now, what are the various steps in order to build the car? What sequence I have to follow? First, build the body. Okay. This involves creating the car's chassis and then building the body using the metal, all those things. Then fit the wheels. Okay. Then fit the engine. After that, fit the steering wheel, fit the gearbox, fit seats, fit essential accessories. Once all these things are done, then my car is built. Okay. See this template method, it is a public void build car. Okay. It is not a virtual method, it is not an abstract method, it is a public contract. Basically, public void build car, it is a public method. Okay. So it specifies these various steps. Okay. And what are these steps? These steps are basically varying parts of your algorithm. Okay. This particular method, the template method, which contains all these steps, are invariant in nature. Either you build a BMW car, either you build a Audi car, electric car, Tata Harrier, these are never going to change. This is the sequence all manufacturers follow, basically. Okay. You can't fit the seats without creating its body. No, that's not possible, right? So these are invariant steps in a template method, or these are the invariant steps of an workflow or a algorithm. Now, what are the variant steps? Can you see the steps? Each and every primitive step inside this template method, basically these are your variant steps or variant methods, basically. Okay. Which can provide their own implementation for each and every type of implementation or subclass you create. Okay. So I'm going to explain that soon. So this is how a template method will be defined, guys. It should be a abstract base class which contain a template method, and each and every step has been provided as a helper method, or you would say a step method. Okay. So these are the methods using which you construct your car. But as it's an abstract base class car, see, your all invariant, sorry, your all variant steps or steps of your algorithm have been made abstract, basically. Okay. So your base class won't give any implementation. It's up to the derived classes to provide implementation as per their need, basically. Okay. So all are basically abstract methods. Now move on to the concrete implementation. Now see, public class Nexon petrol car. Okay. So Nexon is a Tata's brand. So let's see how I'm going to provide an implementation for this algorithm, basically the build car workflow. Okay. See, public class Nexon petrol car. Okay. Now build body. What I'm doing? Building the chassis and body using steel plates for 5-star rated safety. Can you see this? For Nexon car, I am basically building the chassis and body using steel plates for 5-star rated safety. Whereas for Maruti Suzuki Swift or Maruti cars, it may be just 3 or 2 stars or 4 stars. Okay. That's what I'm saying. The variant parts of your algorithms will provide their own implementation. Okay. They basically customize the steps. Okay. Then fit engine, fitting a petrol engine with 96 HP. Okay. For Nexon it is 96, for Harrier it will be 120 HP. Can you see the varying part of your algorithm? Okay. Fit engine. Okay. Like that I have provided various other steps, I have customized them over here. Okay. So same thing, I have created a Harrier diesel car. Can you see? Okay. The first one was a petrol car. Second one is a diesel car. Okay. But still, building of the car, the process of building car is same. It basically consists of all these steps, and these steps are not going to change. Okay. In their order also, basically. Okay. This will be same for any kind of car. So this is a Nexon petrol car. This is the diesel car, and then an electric car. Okay. In case of electric car, just provide your just have a look at this implementation. Okay. Fitting the engine, see here you are not fitting an petrol or diesel engine, instead you are fitting an electric motor engine with 85 HP horsepower, basically. Okay. And also feature wise also you can see the changes. Okay. In some car you are providing steering wheel with tilt and telescopic feature, But in some car you are providing the fitting steering wheel method with just tilt feature. Okay, so these are the basically varying steps of your algorithm. And then what I'm doing, I'm constructing various cars, and on each car I'm simply calling the abstract base class method build car, my template method. If I do a F12, it will immediately take to my abstract classes build car method. This is my template method, and this template method will follow all these steps in this order to build my car. Okay, so let's run this program and see the output. Well, the program runs successfully, and let's see the changes, guys, basically. Okay, see, with the Nexon EV, I built the chassis body using steel plates for 5 stars rated safety. All three cars are with 5-star rated safety, no issues. Okay, if you want, you can basically your abstract method to build the body can contain. Okay, if you don't want to repeat this implementation in each and every method, like this I have done here. Okay, building a chassis and body using steel plate for 5-star rated safety. If you are sure that all your cars are going to adhere with 5-star safety, then put this implementation directly into this abstract method itself, no issue. Only requirement is that you are providing the same for all your products. Okay, all subclasses, but which is not going to happen in real life. So I have provided a different implementation. Now see the engine. So see the wheels now. This has R16 175 wheel, whereas Nexon, which is a petrol engine, which has R16 275. Okay, same step being followed. Okay, my template method, as per my template method, first I built the body. Okay, I fit the wheel. Okay, I fit the engine. Okay, I put the steering wheel, I put the gearbox. Okay, I put the seats, and then I put the essential accessories. Each and every car will go through all these steps only, but only things the way you basically implement those steps is different. Here you have a wheel size of R16. Here you have R16 bar 275. Here it is 175. Here it is R17 bar 300. Okay, here you are fitting a diesel engine. Okay, but here you are putting a petrol engine. Here you are putting a electric motor. Okay, and then same wise, if you see here, you have both tilt and telescopic steering wheel. Okay, but here you have tilt steering wheel with no cruise controls. Okay, and here you have tilt steering wheel with cruise controls. Okay, basically the template method step is not going to change for all the cores. It is same basically, but only thing is the way you provide that implementation, those will change. Okay, the way you customize the steps, the way you provide the extra implementation for your step, that will change. Okay, so I hope you people understood this. Okay, so let me go to my PPT. So the UML class diagram, as already explained, abstract class, my template method, and this template method will contains, okay, various method calls, which are basically my primitive steps in the order. Like you will call primitive method 1, and then you will call 2. Now it's up to the subclass how it basically provides implementation for this abstract base class which contains my template method. So what it does, it doesn't give an implementation for template method. It will never override template method. Do remember this statement. Okay, you should never override the template method. Okay, what happens if you override the template method? You will alter the sequence itself. Okay, you alter the you basically alter the way an object is being constructed. Okay, so that's why you should adhere to template method, and only thing what you can override is this primitive methods can be overridden in your subclasses as per your requirement. Okay, that's why this method is invariant, whereas these step methods are variants in nature. Okay, that's the UML class diagram. So let's go through the pros and cons. You can let consumers override only certain parts of a large algorithm, making them less affected by changes that happen to other parts of the algorithm. Yes, I agree. Okay, so your large algorithm basically, is not going to be affected by any kind of changes because your workflow steps are predefined, your sequence is predefined. Okay, your template method ensures that. Okay, only thing which is going to change is your primitives or your steps as per your requirement, you change it. Okay, and making change to one subclass will not affect any other subclasses. Okay, and moreover, whatever changes you are doing, you are basically doing by inheriting from the base class. Okay, whenever you introduce a new algorithm, okay, or yeah, whenever you introduce a new product, I would say, basically. Okay, so what you do, you basically inherit from the abstract base class, and then you basically provide your implementation to your primitive methods. Okay, that's why changes doing in one subclass or one other algorithm is not going to affect your template method sequence. Okay, you are not going to change you are not going to make any changes directly into your abstract base class. Okay, so you can pull the duplicate code into a superclass. As I already explained, if there are some steps which are same for all the products, okay, for all the algorithms basically. If there are some steps which is same for all the algorithms, you can directly put into abstract base class itself. So one such example is building this body in my example, the car body. As I have decided that I will give 5-star safety for all of my cars. So what I can do, I can take out this. Okay, I can simply remove this method and provide a implementation over here itself, the same implementation here, and make it abstract. Okay, so if you call the abstract method also, it will give you the this result basically. So a car, whatever car you build, it will come with 5-star safety only. Okay, so that's about the pros. And you can, yeah, that's what I already explained. Cons: some clients may be limited by the provided skeleton of an algorithm. Yes. Okay, so this is my template method, this is my skeleton basically. Okay, so this is my template method, this is my skeleton. So whoever wants to make use of this workflow or algorithm, they must be stick to these steps and this order. Okay, they must implement according to this only, they can't introduce a new step over here. Okay, they have to adhere to this template method basically, or the step of activities, I would say. Okay, so some clients may be limited by the provided skeleton of an algorithm. Template methods tend to be, sorry, template methods tend to be harder to maintain the more steps they have. Yes, it will be little difficult to maintain when your algorithm or workflow gets a lot of steps in your template method. Okay, and also it adds a difficulty in debugging also, guys. Okay, so template methods are usually difficult to debug. Okay, so that's one thing you have to take care of. Okay, so well, that's all from the template method design pattern side. Thank you for listening and have a nice day.